Well, we're going to talk about sign diagrams today, which is chapter 22, section C. First thing, the black part right here is our sign diagram. We have a horizontal line, which represents the x-axis, plus and minus signs, and that's where the graph is above or below the x-axis. And then we have what are called the critical values. Those are the x-intercepts, or places where the graph is undefined. Actually, these are vertical asymptotes. So in this case, this funky little graph I drew here, which you have something similar in the textbook, I have on my sign diagram my x-intercept of 3 and my x-intercept of 1. I put a solid line, okay? And then here, where the curve approaches 2 but never touches it, and then this direction it approaches 2 but never touches, I put a dotted line. And now what I do is I basically, when I have it graphed, I just have to look at the graph. So when we're below 1 on the x-axis, the graph is below the x-axis, so the sign is negative. Between 1 and 2, it goes above. Between 2 and 3, it's below. And above 3, it's above, so it's positive. So we have a sign change between each place. That doesn't always happen, but this is a sign diagram to explain some of the things going on with this graph. So we'll do a couple examples. So we have to go through the different things that we need to know while we're doing it. So I have the first two examples are this, x plus 5 and x minus 2. So I need to figure out my x-intercepts. That's the main key. X-intercepts and possible places where undefined. This is going to come up with fractions when the denominator is 0. So in this case, if we want to draw a sign diagram, first thing we do is we figure out our x-intercepts. Just like a quadratic, x plus 5 equals 0. So x equals negative 5. X minus 2 equals 0. X equals 2. So my sign diagram, 0, 1, 2, negative 1, negative 2, negative 3, negative 4, negative 5. Now, 0. This and this are what matter for my sign diagram. Nothing else matters. Now I got to figure out what's going to happen. So I can pick whatever I want. You pick a point somewhere. Now, if you read right above these examples, it talks about whenever I have factors that are like this, I'm going to have a sign change each time. So whatever the sign is here, it'll be the opposite here and here. So what's happening is this is a quadratic, and it's going to do this or this. Now, what should happen if I were to look at this, I'm going to guess that this is positive, this is negative, and this is positive. But we'll verify that. We'll pick 0. So we're going to let x equal 0. So 0 plus 5, 0 minus 2. So I have 5 times negative 2, which is negative 10. So between negative 5 and 2, the graph is going to be negative. So that worked. Negative 10, so that's negative. And I'm going to get the opposite sign over here, the opposite sign over here. So if it's negative here, it's positive here, and positive here. If I had have done this point and found out it was positive, then I would add a sign change and sign change. Now, if you think about it, it's a parabola doing this, crossing the x-axis. It's positive. The values for y are going to be negative, and then they're going to be positive again. Now we'll try one more. We've got 3, 2x plus 1, and 4 minus x. And 2x plus 1 equals 0, x equals negative 1/2. 4 minus x equals 0, 4 equals x. So my critical values are going to be negative 1/2 and 4. So 4, negative 1/2. You can pick whatever you want for a point. Oh, let's mix it up. We'll pick 5. 5's over here. And again, we're just going to have the one sign change and back. So 3 times 2 times 5 plus 1. Now, I know somebody's going to ask it, even though I've said it. You're just picking whatever number you want that you think is going to be easy. So I picked 5. Told me it'll tell me what the sign is out here. And then here will be the opposite. And then here will be the opposite of whatever I got here. You could pick 0. 0 is always a nice easy one. And then I switch the sign there, and whatever the sign is here, it'll be the same over here. But I picked 5. So I have 3 times 11 times negative 1. Well, that gives me negative 33. So that means my graph's going to be negative over here because 5 is over here. So this is negative. Sign change. Sign change. And that's a sign diagram. Now that's going to be useful for us as we move into pre-cal and calculus. Hopefully you're able to follow that. Now, I got a couple more examples. Ones that make it a little tougher. I'll erase. Try and back in my comfy spot. Sorry for the length of the video, but I could have broken it into 2, but might as well do it as one, finish the whole section. Alright, so we've got 2 more examples for this. Actually, there's a lot more than 2. So we have negative x plus 2 squared. And what's the other one? X minus 3, x plus 1. So, for this one, I only have to do x plus 2 equals 0, x equals negative 2. It's my only critical point. Now what this is going to tell me, it's only going to touch the x-axis. So it's going to touch it and then go back. So if this is negative 2, we can pick 0 over here, or you can pick something over here like, I don't know, negative 4. But I'll show you that whatever we get here, it's going to end up the same over there. So we have negative 0 plus 2 squared, negative 4, because 2 squared is 4, and the negative is outside the brackets. So that means it's going to be negative here. And it's going to be negative over here. Because what's happening is if this quadratic is coming up, touching at negative 2, going back down. Proof, negative 4 plus 2 squared, negative 2 squared, which gives me negative 4. Same thing. So, pretty straightforward. That's negative. Negative 4 was negative, so that means over here is negative and over here is negative. Now, everything we've looked at so far only has critical values that are x-intercepts. but we got to pay attention for where it's undefined. So that means the denominator is 0. So here, this is going to be an intercept. This is going to be undefined. Because if the numerator is 0, the whole thing is 0. If the denominator is 0, it's undefined. So x minus 3 equals 0. X equals 3. That's one critical value. The other one, x plus 1 equals 0. X equals negative 1. So my critical values are going to be at 3. Because it's an intercept, it's a solid line. And negative 1. Okay? Now, again, we got to check our sign changes. So it's only going to happen once. So wherever we pick, we alternate the signs. So let's pick 0. 0 is always a safe one. So right here, 0, question mark. So 0 minus 3 over 0 plus 1 is negative 3 over 1 is negative 3. So what does that tell us? Between negative 1 and 3, it's going to be negative. And then I change the sign above 3 and below negative 1. So that means this is going to be positive here, and this will be positive here. And if you never trust it, do the math, verify it, pick, say, negative 2 and 4 and see what you get. And hope that it works, and it does. I just did it in my head. All right. That covers example 6. Example 7, we'll go through that. This video is getting crazy long, but sign diagrams are going to be important, like I said, with pre-cal, maybe even calculus. So the next example, we've got, given the sign diagram, here's the sign diagram. We've got 1, 3, 6. Positive, negative, positive, negative. Given the sign diagram alongside, use interval notation to describe where the function is greater than 0. So, the function is, so where is it greater than 0? Function, we're going to use, what notation did they want? Interval notation. So, we're talking about x. And it's greater than 0 between 1 and 3, or greater than 6. Okay? That's it. That's our interval notation for that. For part B, it wants greater than. So I made a mistake because it's only greater than. We got to get rid of those. Now they want greater than or equal to. And I just noticed this is a dotted line, which is going to become important. So we're talking about x again. 1 less than or equal to x, because this question's asking greater than or equal to 0. Less than 3. It can't equal 3 because it's undefined at 3. Or x greater than or equal to 6. Solid line, so we include it. And so all we're doing is writing a set notation or interval notation based on what we see here. If it had been x less than 0, we would have picked this section and this section and wrote a statement for that. And I'm pretty sure that covers everything for section C. It does.